Good morning, dear students. Welcome to another session of microwave and antenna. So in yesterday's discussion, we were solving one of the problem in which we came across one aspect that is what we were missing. So in the problem, yesterday's problem, we missed out one calculation over here. First, we estimated what is the direction of the maxima, that is the peak values. Then we estimated in which direction I am having the nulls by using this equation, that is sine n psi by 2 equal to 0. If I equate this and obtain what are the angles for 5 for which I'll be obtaining the directions of the null values. Apart from this, I need to identify along which direction does the side lobes have a peak. So in order to obtain that, we need to make use of another equation, that is sine n psi by 2. This parameter, I need to equate it to 1. So when I simplify the equation and I obtain the values of phi, so those all angles will be giving me the direction along which there are peaks for the side lobes which are present. So three parameters we need to estimate. So in this problem, yesterday's problem, we were missing out that calculation. So pertaining to that, we can observe the complete solution in this case. So here we can see that the same problem which we were discussing yesterday is given over here. What we have four isotropic point sources which are placed lambda by 2 meter apart. The power applied with equal amplitude and the phase difference of pi by 3 between the adjacent element. Determine the beam width between first null. So what all parameters are given? He specifies that there are four isotropic point sources. So n is equal to 4 and the distance between two adjacent sources is lambda by 6, and delta, which is the phase difference, it is given as pi by 3. So in we use this parameters in psi is equal to beta d cos phi plus delta. So when we simplified it, what we got pi by 3 into cos phi plus pi by 3. So this is the value of psi for the given condition. So this is the value of psi what we had obtained for given condition. Now if we want to obtain the direction of maxima, what we do is we equate psi is equal to 0. So when we equate psi is equal to 0, we obtain certain values for phi. We obtain certain values for phi. So those values, that is the angle values, gives us the information regarding in which direction I am having a maximum. So when we solve this problem, right, what we obtain is we obtain phi is equal to plus minus 180 degrees. So what does this indicate? So if you consider that the sources are placed, the four sources are placed along phi equal to 0 degrees axis. So I'll be having 180 degrees at this end. So what is this specifying? If I move from this end to this end at 180 degrees, I have a peak value, and at minus 180, it implies that you are moving in the clockwise direction. That is, from this point to this point, it will give you minus 180 degrees. So at only along this direction, that is only along this direction, I am having a maximum for this case. So that is the first thing. I got to know that in which direction I am having a maximum. I am having a maximum only along plus minus 180 degrees. That is as associated with phi. So next, yesterday we obtained the null values. So how do I obtain the null values or the direction of the minima? Minimum is what? Minimum is the field value has to be 0. In order to estimate that, what we have to do, we have to equate sine n psi by 2 equal to 0. Now when we simplify this equation, so you can observe n psi by 2 is equal to sine inverse of 0. What is sine inverse of 0? It will be either 0 degrees, 180 degrees, or 0 degrees minus 180 degrees, 360 degrees minus 360 degrees. It's so on continues. So in terms of radians, it is 0, pi, minus pi, plus 2 pi, minus 2 pi. So it is all these values. So therefore, in general, what we can write is we can write sine inverse of 0 is equal to plus minus k times pi, where k is equal to 0, equal to 1, equal to 2, and so on. So that is what you will be obtaining. So sine n psi by 2 is equal to plus minus k into pi. So when we obtain this equation, we try to simplify this entire parameter. N is 4, psi is given by pi by 3 into cos phi plus pi by 3, this parameter, and the whole parameter is divided by 2. So when you simplify for phi, what you will be getting is, you will be getting this value, which is equal to plus minus cos inverse of minus 1 plus minus 3k divided by 2. And yesterday, as we discussed, now in this part, if I consider minus 1 minus 3k by 2, what happens is, if I substitute k is equal to 1, what I'll be having? I'll be having 1 minus 3 by 2. So here I can see that this value is much lesser than minus 1. It is much lesser than 1 minus 1, because when I take the cos of any angle, the value will be in the range of minus 1 to plus 1. Cos of any angle will be in the range of minus 1 to plus 1. It cannot be lesser than minus 1. It cannot be greater than plus 1. So therefore, what happens is the negative sign has to be neglected. So what happens is, we need to consider only the positive. So it will be 1 plus 3k by 2. For any of the negative values, or for any of the k values in the negative range, I will not be able to obtain the cos inverse, because it will be, this part will be lesser than minus 1. So therefore, what we do is, we need to consider the plus 3k by 2 in this case. So now we substitute for the all the possible values of k, and see for which all possible values of k we will be obtaining the phi value. So when I substitute k is equal to 0, I obtain phi as plus minus 180 degrees. When k is equal to 1, I obtain phi as, when I simplify this parameter, I'll be obtaining it as plus minus 60 degrees. Now if I substitute k is equal to 2, so when k is equal to 2, what happens? It will be minus 1 plus 3 plus 3. Since 3 into 2, 2 and 2 gets cancelled over there. So this will be equal to 2. And I don't have cos inverse of 2, because it is going out of range. This is greater than 1. So I cannot have cos values. So therefore, what happens is, after k equal to 2, you substitute any value for k, you will be getting this part, which will be greater than 1. So therefore, only these two are possible at present moment. Now we observe that for k is equal to 0, we are obtaining the direction of minima, that is the direction of null, is given as plus minus 180 degrees and plus minus 60 degrees. But when we are trying to estimate this, we need to have a look at the direction of maxima. So what we do is, we check out what is the direction of maxima. So direction of maxima, here you can see that it is given as plus minus 180 degrees. So first preference, you give it to the maxima. So plus minus 180 degrees, if maxima is present along plus minus 180 degrees, then it is implied that no other condition will be satisfying in that direction. So therefore, what happens is, here you can observe that for k equal to 0, we have obtained this direction of minima, but in this direction, maxima is present. So therefore, this one I cannot consider. This one I cannot consider, because in this direction already I have a maxima. So therefore, I neglect this. So only possible value is along plus 60 degrees and minus 60 degrees. Only along this direction, I'll be having a minima, that is null. Now, apart from this, we need to estimate one more parameter, that is the direction of the peak values for the side lobes. So I need to estimate the side lobes. So for side lobes, what I do is, I consider sine n psi by 2 equal to 1. I equate this and try to see for what all values of phi I'll be able to obtain the direction of the side lobe. So when we try to simplify this, what we have is n psi by 2 is equal to sine inverse of 1. So for sine inverse of 1 will be equal to what all parameters we need to identify. So sine 90 is 1, sine minus 90, if I consider the magnitude, it is again 1. Then if I consider sine 3 pi by 2, it is 1. Sine, so in this way, what we do is we try to estimate. So we have for pi by 2, 3 pi by 2, so on. So when we have this condition, suppose if I want sine inverse, so this 3 pi by 2 will be minus 3 pi by 2. Similarly, then next we have 5 pi by 2 and so on. So what this will specify is for plus minus 3 pi by 2, for plus minus 3 pi by 2 and so on. This condition will be satisfied. So therefore here you can observe that for all the odd values of pi by 2, so here I have the multiplication by 1, multiplication by 3, multiplication by 5 and so on. So for all these possible values, I have the condition which is satisfying for this case. So how do I write it in general form? So this one has to be always a odd number in this case. So I try to simplify that. So how do I specify? I specify that value as 2k plus 1. So if k is equal to 0, what is the value? This value is equal to 1. If k is equal to 1, then this value 2 into 1 plus 1, which is 3. If k is equal to 2, this value is 5. So you'll be getting all the odd values. So here what we have plus minus 2k plus 1 into pi by 2. So this n psi by 2 will be equated to this parameter. Now what we do is we substitute the known values of n and psi, and when we simplify this overall equation, what we'll have is we will have phi is equal to plus minus cos inverse of minus 1 plus minus 3 times 2k plus 1 divided by 4, where k is in the range of 0, 1 and so on. Now, in some cases, say it might be tedious for you to identify whether plus has to be considered or minus has to be considered. So no need to worry about that also. So what you do is you substitute the value of k, and see what parameter you are getting in this part. If you are getting it less than 1, then you discard that point, and if you're getting more than 1, you discard those conditions. Rest all, for what all things you are able to obtain the angles, you try to obtain it. So you substitute different values of k. So k is equal to 0. It will give me what? Phi is equal to minus 1 plus minus 3 by 4. So if I take minus over here, that is 1 minus 3 by 4 in this case, what happens is this overall term is less than 1, So I neglect the minus in this case. So if I consider minus 1 plus 3 by 4, so I am able to satisfy the condition. So I'll be able to obtain the cos inverse. In this case, I'll not be able to obtain the cos inverse, but for this case, I'll be able to obtain the cos inverse. So therefore, you try to solve the problem. So when you try to solve this equation, what you will be having is you get it around plus minus 104.5 degrees. 104.5 degrees. So similarly, you try for k is equal to 2. K is equal to 1. When k is equal to 1, what happens is you have minus, say plus minus, it will be k is equal to 1 will be 2 plus 1 divided by 4. So it will be minus 1 plus minus 6 by 4. So here if you just observe what will be the condition. So this is greater than 1. This is greater than 1. So when I take minus 1 and minus 6 by 4, I'll not be able to obtain cos inverse. But when I take minus 1 plus 6 by 4, try to see what is the value for this. So when you obtain the value for this condition, you will be able to observe that it will fall within some category. So based on that, what we can specify is we will not be able to obtain the side lobe in that particular direction. So here we are able to obtain the side lobe. Here we are able to obtain the side lobe. I haven't measured the value whether this is correct or not. I am just trying to give you the overall analogy of how the problem is being solved. Okay. So this is the way we need to solve it. So based on yesterday's discussion, that is based on these conditions, right? What we have along plus minus 180 degrees, I have a maximum. So I should have a maximum at this point in this direction. And I'll be having nulls in these two directions. I'll be having nulls in these two directions. So at plus 60 degrees and minus 60 degrees, I'll be having a null. So here you can observe that if here we are having nulls, right? What about the other angles? In this part, I'll be having the radiation, and in this part also, I'll be having the radiation. But here I'll be having minima, and in this direction, I'll be having a maxima. So therefore, what happens is from this point to this point, I'll be having the main lobe. I'll be having the main lobe. And from this angle to this angle, I'll be having the side lobe. Now, as per this given angle, right, if you just observe, you should have at plus 104.5 degrees. But this condition is not possible. This one is not possible. If this is the case, right, this one is not possible. So why is here you can see that you are having nulls only at these 2 points and you are having maximum over here. Nothing else is specified in the other direction. So therefore you have only two possible things over here. So what happens is here, if you're having a main lobe, you cannot have a side lobe in this region. You cannot have a side lobe in this region. If I measure the angle, 104 will be somewhere here. So here already main lobe is there. So I cannot have a side lobe. I cannot have a side lobe. So if I try to estimate the values for different values of K, right, you will be able to obtain different angle values. So in that, one angle will be turning out in phi equal to 0 degrees. You have a maximum, you have a peak value for the side lobe. You have a peak value for the side lobe. So here you represent a side lobe. So this is the solution to the problem. In yesterday's problem, right? So please rectify this. Please rectify this. This is not the correct solution. Okay. Here they have given the solution. And what about the beam width between the first nulls? So if I start from the main beam, where is the first null occurring? So if I move around, the first null occurs over here. And if I move in the other direction, the first null occurs here. So this overall angle, what I am having, is nothing but beam width between first null. It is beam width between first null, or sometimes it is termed as first null beam width. You try to estimate what is the angle. So it is nothing but 360 minus 120 degrees. That is, this 60 plus this 60 will be gone. So 120 degrees will be gone. So it will be around 240 degrees. And what about the half power beam width? Half power beam width is assumed to be nearly equivalent to half of the beam width between first null. So which is around 120 degrees. So that is what is given over here. So now let us see another problem, and then we can have a clear implication of how this problem can be solved. So we'll consider another problem over here. Consider this one. So here we have a linear array that consists of 4 isotropic point sources. The distance between adjacent elements is lambda by 2. Now the power applied is with equal amplitude and a phase difference of minus dr. Obtain the field pattern and find the beam width between first null and half power beam width. So there are all the parameters they have specified. They have specified that number of sources n is equal to 4, distance between two adjacent elements, that is d is equal to lambda by 2, and directly they have specified that the phase difference is minus dr. So this is nothing but delta. Delta is minus dr. We need to obtain the beam width between first null, half power beam width, and the field pattern. So now, since we have all these parameters, let us try to estimate a few of the values. So d is equal to lambda by 2 will give me dr, which is equal to beta times d. So when I simplify this, I get dr equal to pi. I get dr equal to pi. And number of sources is equal to 4. And he has specified delta is equal to minus dr. So therefore, what this implies, delta is equal to minus pi. Now, therefore, what is psi equal to? Psi is dr cos phi plus delta, which is dr is pi cos phi minus dr. So dr is directly equal to pi. You can substitute it here itself. So psi is equal to dr cos phi minus 1. But what is dr? Dr is equal to pi. Dr is equal to pi. So we have cos this thing minus 1. So first and foremost, we need to identify what is the value of psi. So once we have obtained the value of psi, right, we can go ahead with estimating the direction of maxima or the peak values. So I have peak. I'll be able to obtain the values of peak for when I equate psi is equal to 0. So when I equate psi equal to 0, I'll be able to obtain the direction of the maxima or the direction of the major lobe or direction or the peak values. So here dr is pi. So wherever required, you can just substitute it. So now we need to equate this one equal to 0. Now dr is not equal to 0. Then what we can do is we can equate this part to 0. So therefore what we have, cos phi minus 1 is equal to 0. So therefore when I simplify it for phi, right, phi is equal to cos inverse of 1. So for which all possible values I can have, this condition is for 0 degrees, for plus minus 180 degrees, for plus minus 360 degrees, and so on. So whenever we are writing this, right, we generally write it as this equal to plus minus cos inverse of 1. So therefore we have these possible values. So if I write it in a general form, right? What is the condition I can be having? You can see that if phi is equal to 0 over here, then I have 180 degrees. So as per this condition, right, at 0 degrees I have a maximum. So along this direction I have a maximum. Then at plus 180 degrees I have a maximum. At 180 degrees I have a maximum. Now if I take it as minus 180 degrees, plus 180 degrees is in this direction. If you move in the other direction, you'll be having minus 180. So along 0 degrees and 180 degrees, I have the peak values for the given conditions. For the given conditions. So now next I need to identify the direction of the nulls or the minima. So in order to do that, we equate sine n psi by 2 equal to 0. So when we equate this and simplify this, what we obtain is we obtain phi is equal to plus minus cos inverse of 1 plus minus 2k pi divided by n times dr. So now you substitute n and dr over here and you try to simplify the equation. So again, here when we put k is equal to 0, we get phi is equal to 0 degrees. Phi is equal to 0 degrees. Now this has to be discarded. Why? Because already we identified that at phi equal to 0 degrees we have a maxima. So next you substitute k is equal to 1. So when you substitute k is equal to 1, you get phi is equal to plus minus 60 degrees. When k is equal to 2, you get phi is equal to plus minus 90 degrees. When k is equal to 3, you get phi equal to plus minus 120 degrees. When k is equal to 4, it is plus minus 180 degrees. When you continue, these values keep on repeating. These values keep on repeating, and at some points what happens is this value will be greater than 1. This value will be greater than 1 or less than 1. So for those cases you have to neglect it. So if you want, you can continue and just observe whether you are repeating the values, that is plus minus 60 plus minus 90. So you have to try it out for all the possible values and stop at a moment where you understand that okay, these are the possible values, and we cannot have any null values in any other directions. So here you can observe that in what all directions I am having plus minus 60 degrees I have a null, plus minus 90 degrees I have a null, plus minus 120 degrees I have a null, plus minus 180 degrees I have a null. So if I keep on continuing, either these angles will be repeated, or for few cases what happens is this value will not be able to obtain cos inverse, because either it will be greater than 1 or it will be less than minus 1. So this is the case of the nulls in which direction they are. Now next we need to identify the side lobes. So for side lobes, we equate sin n psi by 2 equal to 1. So and when we simplify this, what we obtain is, we obtain phi is equal to plus minus cos inverse of 1 plus minus 2k plus 1 into pi divided by n. So now what we need to do is, we need to substitute for k equal to k equal to 0, 1, 2, 3, and so on. So now next what we do is, if we substitute k is equal to 0, so here we are obtaining phi equal to plus minus say 41.1 degrees. When k is equal to 1, that is in the above equation, when we substitute in this equation, when we substitute, so when k is equal to 1, we obtain phi equal to plus minus 75.52 degrees. When k is equal to 2, phi is plus minus 104.48 degrees. When k is equal to 3, phi is equal to plus minus 138.6 degrees. But when you go for further value, right, when k is equal to 4, what happens is, here you can observe that when you substitute this, it will be 1 plus 9 by 4. So when I simplify this, it will be around say 2.5. So what is happening? I am getting 3.5. So this is actually greater than 1. So if I take the positive sign also, I'm not able to get the result. And what about negative? That is 1 minus 9 by 4. It will be 1 minus 2.5, which will be equal to minus 1.5. Here you can observe that this value is less than minus 1. So whether you take plus or minus, you will not be able to obtain the cos inverse. So even if you still go further, right, if you substitute k equal to phi, for that conditions also, you will not be able to obtain the phi values. So therefore, you stop over here. So after this values, you will not be able to obtain the angles for phi. Okay. So now how do I represent the radiation pattern? So I have obtained the direction of maxima, direction of the nulls, and the side lobes. And how do I obtain the representation of the radiation pattern? So in which direction I am having the peak values? I am having the peak values along 0 degrees and 180 degrees. Okay. And I am having the nulls in these possible directions. And lastly, I am having these are the directions of the side lobes. So let us see how we can go ahead. So this is phi equal to 0. This is 180 degrees. So in these two directions, I should have a maximum. So apart from this, I cannot have any other parameters. So first we identify the direction of maximum. Next we identify the direction of the nulls. So here we can see that the direction of nulls is plus minus 60, plus minus 90, plus minus 120, and plus minus 180. Now this condition I cannot consider, because in plus minus 180 degrees already I have a maxima. Okay, so plus minus 180 degrees I have to discard this value. Only at these 3 points I'll be having the nulls. So plus minus 60 degrees. So plus minus 60 degrees is, if I move in this direction, plus 60 degrees is this one, and if I move in the other direction, minus 60 degrees is this case. So next one is plus minus 120 degrees. So plus 120 degrees is when I move from phi equal to 0 up to this direction in say anti-clockwise direction, 120 degrees. So along this direction I am having a null, and minus 120 is in the other direction. So minus 120, I have a null over here. So I got null set plus 60 minus 60 plus 120 minus 120. So these are the two possible values along which I have obtained the nulls. Is there any other point? So here we have plus and minus 90 degrees also we have a null. So when I move in this direction at plus 90 degrees, I have a null. And when I move in the anti-clockwise direction at minus 90 degrees, I have a null value. So here you can observe that maxima is along these two directions. Then null is along these directions. Null is along these directions. So if you make an observation, so there should be a radiation which is present between these two angles. There should be a radiation present between these two. There should be a radiation present between these two. There should be radiation present between these two, and similarly the other cases. So if you make an observation over there, since between here I cannot have a null, only along 60 and minus 60 I have a null. So here I should have a radiation pattern. Here I should have a radiation pattern. Here I should have a radiation pattern. Here there should be a radiation present. Here radiation present, and here radiation present. But already you know that along phi equal to 0 degrees and 180 degrees you have a maximum. So in this part you will be having the main lobes. In this part you will be having the main lobes, and in rest all parts. So here you should have a radiation. Here if you should have a radiation. So here also, here also. So if you logically think, if direction of maximum is over here, then this part is considered for the main lobe. This part is for the main lobe. So here I'll be having a side lobe. Here I'll be having a side lobe. Here I'll be having a side lobe, and here I'll be having a side lobe. But in which direction the side lobe is present? It is given by these angles. It is given by these angles. So what he specifies that at plus minus 41.1 degrees, you can have a possible side lobe. But if you make the observation, right? If you make the observation, you are having a null over here. You are having a null over here. So in between, you are having a radiation. But in this case, what is specified along phi equal to 0, you have a peak value. You have a peak value. So this is nothing but the major lobe. This is the major lobe. So if I have a major lobe over here between 60 and minus 60, I cannot have a side lobe present over here. So this condition has to be discarded. This condition has to be discarded. You cannot have a side lobe at plus minus 41 degrees. So plus minus 41 degrees will fall somewhere here. But you are observing that the nulls are occurring at plus minus 60, plus minus 90, plus minus 120. And you're getting that phi is equal to 0 and phi equal to 180 degrees, you have a main lobe. So if that is the case, then I cannot have a side lobe which is present over here. I can have a main lobe or the major lobe which is present between these two. So it is based on all the conditions what we are considering. Now, next it is specified that at plus minus 75.52 degrees, I have a side lobe. That is a peak value of the side lobe is present. So here you can see that at plus minus at plus 75.52 degrees along this direction. So here, as we discussed, here there should be a radiation, and as it is specified that only in these two directions I have a maximum. So this will lead to what? This will lead to side lobe. This will lead to the major lobe. This will lead to the side lobe, and you have a peak in which direction? 75.52 degrees. So therefore, what happens is between 90 and 60, you have a side lobe in which the peak is falling in the direction of 75.52. Similarly, if I move in the other direction, between 60 and between 60 and 90 degrees, minus 60 and minus 90 degrees, at minus 75.52 degrees, I have the peak of the side lobe. Therefore, I have a side lobe which is present over here. So similarly, we need to consider the other parameters. So here we have at plus minus 104.48. So here you can see that 104.48 falls between 120 and 90 degrees. So here there is no major lobe present. So this side I can consider, and in this direction I have a peak of the side lobe. Now plus minus 138.6 degrees. So it is greater than 120, that is 138 degrees, and when you consider minus 138 degrees, you are moving here. So it might be somewhere here. This might be 138 degrees. Now here, as we have observed, along phi equal to 180 degrees, I have a peak value. So peak value is nothing but it is referring to the main lobe. It is referring to the main lobe. So therefore, what happens is along this direction, along with this direction, I cannot have a side lobe which is present between 120 and minus 120. I can have only the major lobe. So even this part also has to be discarded. So in this case, this one and this one are discarded. You have only 4 side lobes. You have only 4 side lobes. So this is the how we obtain the radiation pattern. So first you have to obtain all the possible angles. So first plot where the peak value is, This peak value is an indication that in that direction I am having a major lobe. Then apart from that, try to identify where nulls are there. So between two nulls, you will be having a radiation. So that is between this null and this null, you will be having a radiation. That is, you will be having a lobe over there. That is how I can put it. Between these two angles, I'll be having a lobe. Whether it is a major lobe or minor lobe, you have to decide. So here, since I have maximum which is present, that is a peak value which is present between these two angles and these two angles, I can specify that these two are the major lobes. And at rest of the parts, I can have the minor lobes. And in this direction, if you are getting along the main lobe, if you are getting the angles for the side lobes, those parts have to be discarded. We need to identify what is the beam width between first null and half power beam width. Now, whenever we are estimating the beam width between first null or half power beam width, it is always associated with the main lobe or the major lobe. Now here, since two lobes are there, no need to worry. You consider one of the main lobes. So in this main lobe, what you have, you can see that where the first null is occurring. So if I move from phi equal to 0 degrees with respect to this, it is beam width between first null. Where is the first null occurring with respect to the main lobe? So here, if I just observe, so first null in this direction is occurring at 60 degrees and first null in the other direction is occurring at minus 60 degrees. So what does this imply? This gives us the information that this is the beam width between the first nulls. This is the beam width between the first nulls. So beam width between first null for the given condition is 60 degrees plus 60 degrees, which is around 120 degrees. So here also if you measure it, so if I start from, if I start along with this major load, so I have a peak over here. So if I measure the angle, so I am, so if I start over from here, I am getting a first null over here and I am getting a first null in the other direction over here. So this angle is how much? This angle is 60 degrees. So 120 and 180. So the angle is 60 degrees and here also the angle is 60 degrees. So when I measure the overall angle, it is again 120 degrees. So beam width for the given beam width between first null for the given condition is 120 degrees, and half power beam width is nothing but from peak value. If it is field, you have to move down by, you have to consider 1 by square root of 2 into the maximum value. So it is indirectly, it will be falling somewhere in this direction. This will give you half power beam width. So generally what is done is half power beam width is considered nearly equal to beam width between first null divided by 2. That it is half of the beam width between first null. This is an approximate value of half power beam width for the given condition. So for this case, it is around 60 degrees. It is around 60 degrees. That is when I consider for 1 by square root of 2, and if it is power, it is 1 by 2. So this angle will be around 60 degrees. So this is all for today. Let us meet in the next session in which we'll be continuing with the next part of this module. So thank you.